the security instrumentation is this in the whole like security posture piece is this idea that like we should always make time to think about security, and they call it shifting left on security. So it used to be that you'd write a bunch of code, and at the very end, your security team would be like, yes, I'm going to give it my blessing, and you can go out. But that's way too late. The idea is that you should actually have security best practices in from day one.
Hey there, welcome to Book Overflows, the podcast for software engineers by software engineers, where every week we read one of the best technical books in the world in an effort to improve our craft. I am Carter Morgan, and I'm joined here, as always, by my co-host, Nathan Toups. How are you doing, Nathan? Well, thanks for listening, everyone. Like, comment, subscribe wherever you're at. Make sure to share the podcast with your friends, share it on LinkedIn. You can tag us on LinkedIn if you want. And yeah, we're excited to have you here. And make sure to check out, while you're here, our interview with Kirill Bobrov, author of Grokking Concurrency. That was a fun one. You know, he is not, I believe we were his first podcast interview ever, which is unusual for most of our authors, but pretty neat, huh?
So cool. And yeah, he's a great all-around person, and had some cool things to say about his experience on LinkedIn and stuff too. So that was it was cool. I love engaging with the authors.
Yeah. This podcast started out as as we like to joke, as a book club masquerading as a podcast, but it's quickly just turned into a vehicle for Nathan and I to meet cool people. So we're very happy about that as well. And yeah, we're excited about things we got working through the pipeline. We always try to interview as many authors as we can, and when they happen, they happen. But you're always entitled, I guess I would say, to our weekly episode discussion. And we've got that this week. Finishing up the DevOps Handbook. This has been quite an endeavor, huh, Nathan?
Yeah. It's funny too. I think this might be the first book where the further I get into it, the more I'm like, yeah, this is a great book. Like I wish that if there was a version 3, that they would maybe make it more periodic and give me, like, you know, maybe some examples, get into the nitty-gritty, do some philosophy on it, and then rinse and repeat. Because I feel like what we saw was a bunch of like abstract framing, and then some ideas on how you implement, and then like really into the nitty-gritty at the end here, which of course I loved. I think that there's a type of reader, and we'll talk about this at the end of the episode, that could really just read parts maybe 3, 4, 5, and 6, and that's all they need out of the whole book, right?
Yeah, well, I guess we can get right into our general thoughts. This is week 3 of covering the book, and so I mean, it's the DevOps Handbook. We won't introduce each author again. We got Gene Kim, Jez Humble, Patrick Dubois, and John Willis. And yeah, it's just the definitive guide for applying DevOps principles across entire organizations. Yeah, I mean, I think it's interesting you say you liked it more as it went on. I had kind of not the opposite impression, but we talked about with the first episode, parts 1 and 2 being like trying to really sell you on the principle of DevOps, which, like, I think, if anything, the DevOps movement has been a victim of its own success, in that there's not a whole lot of like selling needed at this point. And so, for people like us who are very familiar with it, parts 1 and 2 are not entirely necessary. Loved parts 3 and 4. That really got into the nitty gritty, I thought, of like, okay, well, what does it actually look like to implement DevOps in an organization? Parts 5 and 6, this is just a me thing, but anytime we start talking about security, my eyes glaze over.
Wow. Okay. This will be a good episode then, because anytime we talk about security, that was literally every elective I took at Georgia Tech, right? So like I'm like security obsessed, and I'm this whole conversation of shifting left on security. So this is a good experience for me, because I've experienced the engineer's eyes glaze over when I get excited about something at work, and I'm like, okay, so Carter and I will be a good sort of like back and forth on this. Great.
Well, I need to be sold. I am convinced of the importance of security, but I just, yeah, it's not something I naturally gravitate towards. And I like building things, and anytime security comes along, it's like you have to slow down and like grr. So
the fun police. Yep.
yeah. But we'll get into all of it. Part 6 is really about security. Part 5 is about continual learning and experimentation. But I guess we can just get into it right now. I mean, let's start with part 5, continual learning and experimentation. I mean, anything that really stands out to you in this chapter, Nathan? I did like a lot of the case studies here.
Yeah, I really hate this sort of like fuzzy stuff where people are like, oh yeah, we have to create a safe space, and sometimes people, it's like it gets too touchy feely. Except I do believe that you can't have good experimentation and you can't have teams taking risks unless you make a safe space. And I think part of that is, by safety, I mean, not that you'll never hurt someone's feelings. That's not, I think you need to have, radical candor and things like that, what we've talked about. To me, a safe space is if something blows up or if you find out that it's a failure of an idea, that as a group we can kind of identify, well, what was a failure? And maybe we can figure out a way to take a risk that takes a smaller experimentation window. Or maybe this team and this team had experiments, but our information's so siloed that we don't actually, I don't know that another team already tried 3 of the 5 things that I tried. And I think this section was really good as far as like reminding us that it's our duty to share our findings, whether they're good or bad, right?
Yeah, I think like you talk about, when we talk about creating a safe space and a safe culture, that's not this idea that no one will ever misspeak or no one will ever hurt your feelings or no one will ever, maybe accidentally offend someone. But it's that idea of being able to pursue risks, both big and small. I've seen mistakes in a macro sense and a micro sense on that level. The micro sense is something I think a lot of us are familiar with, the idea that like, you brought down prod and that's a big deal and right. You're punished. I working at, both my examples come from Amazon. One in like a macro sense and one in a micro sense. The micro thing was funny. Something that Amazon did where they like were trying to do the right thing, but it just cracked me up. Is like, if there was an incident, generally you are responsible for writing the COE, the correction of errors. And they insisted so much that writing a COE was not a punishment. For what it's worth, I believed them the first time. But they insisted so much that it wasn't a punishment that I started to think it might be a punishment.
Right.
Right. And I don't know. Maybe that just was a poor culture fit thing. I tend to take people at their word, but I know some engineers can be skittish people who need lots of reassurance, but I just started to get suspicious.
It's funny. I think it's kind of like maybe the tactics that my parents used to make me eat my vegetables, right? So you're like, this isn't a punishment, right? Like but they're like, yeah, you have to, like, you're not finished unless you eat your vegetables with dinner. We use a different tactic with our daughter, which is that, first of all, we try to make vegetables absolutely delicious, lots of good oils and salt and heat. But the other one is that, like, if you teach somebody to listen to their body and say, hey, look, if you eat all the like sugary sweet stuff first, and then you try to eat the healthy stuff second, your tummy could hurt and you're actually not going to get good nutrition and it could affect your sleep. And we kind of get her to be more mindful about why we eat vegetables, right? Like, oh, that's nutrient dense and it actually like helps with digestion. And as she's gotten older, I think this has been really helpful. She has a very healthy relationship with food and like thinking about these things. I think the same is true with like blameless postmortems, is that, and then other sort of corrective measures. If you're showing someone why eating your vegetables is good, that this is just a part of a balanced diet, the organization needs it, it's a part of healthy operation. But if you give it in this thing of like, hey, and by the way, you must eat your vegetables before you can do more fun stuff. Yeah, that I think that there's a dysfunctional way that you can actually like enforce a healthy behavior, but do it in a way that feels like a punishment. And yeah. One of the things I loved about this is, and I think I've been only in one organization that was really good about this. It was in chapter 19, and they talked about learning from near misses. So a lot of times, when you have responsive stuff, it's like, well, my boss is going to look bad, and his boss is going to look bad, or her boss is going to look bad if we don't write this good postmortem and do these other things. But they actually said, hey, let's say we caught something before it became a problem. Something showed up in the logs. somebody just randomly was doing something and realized there was like a fundamental error. It wasn't user facing yet. Treating that as if it was just as serious of an incident as a Sev 1 or Sev 2 or something. And by Sev, I mean severity rating. Sev 0 means like the whole website went down. Sev 1 is like a major outage, and there's like these other pieces. But a pretty serious severity score. If you treat it internally, it gives you something else that they bring up later in the book, which is they call them game days, which again turns out the same organization that was really good about doing near misses also was really good at game days. Again, for the uninitiated, and one of the things the book brings up, a game day is kind of like a scrimmage that a team would do before the real game, right? Scrimmage being that they try to make the event, the outage, as real as possible. And so maybe this would be, we do something to staging server, we all treat it like it's normal. Or I've even seen organizations that actually cause minor outages on production, kind of like chaos engineering, where they have to see what corrective measures can come into place. And I think it's a huge deal because it gives you buy-in, right?
I've done game days before. It just, and I want to talk about that. I've just about risk taking though. I've seen in a macro sense, Amazon did this as well, where Amazon had previously had a great culture of, like, if you signed up on a team that was taking a big risk, like maybe you're trying to build the next generation of Alexa or, Amazon Auto or whatever, I don't know. And it failed, like, it's fine. Amazon would just shuffle you to another team and like no harm, no foul, and take a big swing. And one of their more recent round of layoffs, they laid off a lot of those like big swing teams. And so it really chilled the culture of like, well, I'm just going to sign up with the projects that are for sure making a lot of money. It's a tough thing to not screw up. As far as game days go, game days are hugely valuable. Also tough to simulate. At my last job, we were having that problem where like theoretically we were supposed to have a game day, but like we didn't have a staging environment. And so it's like, what are you supposed to do aside from like actually break production? When you've seen people break production, because I've seen that work if your production is like huge. Like, for example, at a big company, like Meta, and when we talked about this in the last episode, like their changes, they'll roll out to like just 1% of users or something like that. Or I've seen it, like we're just going to break Zimbabwe, right? Because like we don't have a ton of traffic in Zimbabwe. It's harder if you only have like one region that you're operating out of. How have you seen people break production in the past?
So it's interesting. I have not been in an organization mature enough to do the production stuff. Like I've read from the sidelines, and I have a friend who he worked at a place that made like HR software that was kind of one of these rapid scale companies. And they did full end-to-end game days. They actually talk about this in the book, and it was cool because I'd heard his personal experience with it, where they talk about communication tools being actually a critical thing to test, right? We don't think about it, but like if the outage actually causes you to no longer be able to use Slack, or causes you to no longer, your email to go down. A lot of times, you talk about all this HA and load balancing and all this like cool stuff that you have in your infrastructure. But if you go one layer of the onion further out, all of your assumptions about how you're going to coordinate these things or how you're going to communicate just completely end. And I thought it was cool. Like Google, they talked about at one point, actually, they would do like wild game day stuff, like alien invasion, earthquake that takes out, the entire Bay Area, San Francisco area, so that it's cut off from the rest of the Google infrastructure. Obviously, you have to be a large organization to be able to pull those kind of things off. But to a lesser extent, I have seen it. Most of the smaller organizations I've been in, we have a staging environment. We don't do the pure version of trunk-based development where it is that you have all these like canary deploys and a single deployment environment, because somebody at Google scale, you can't make a server-to-server replica of what production looks like, right? Your production is like larger than the entire compute power of parts of Europe and Asia combined, things like that.
It's I mean, as far as game days go, I think it's funny. You talk about communication. during game days. And I thought that was funny because when I was at Amazon, the reason I ultimately left Amazon is because they had hired me remote. They wanted me to move to Seattle, and that was not something we really wanted to do. And then they were really selling all the benefits of in-office work, but like in a weird, vague way, right? Like Amazon really prided themselves on being data driven, and so a lot of employees, when the decision was made, were asking like, "Can you show us the data on how we've improved?" And they never would. Management, they would say like, "We don't have the data, but we know that it's working." And that was another thing that really broke a lot of trust with employees.
Trust me, bro. Yeah.
Yeah, they try exactly right. At least at my current place, we're in office, and like, there's no one trying to say it's justified by data. They're just saying like, I'm the CEO and I like this. I'm like, you know what? I respect it. But it's I thought that was funny because I think that's actually a huge advantage that remote teams have over in-person teams, is when incidents happen. Because a lot of time an incident is going to happen at 9 p.m., right? 10 p.m. And the whole team already being very like that's the default method of operation, is working physically alone, debugging things, and then getting on Slack or Zoom or what have you, and solving it. And I also found that interesting at Amazon. I think by far the moments I'm proudest of when I worked at Amazon are big incidents, and when we would all have to get on a call and work hard to resolve something. And even when they'd moved back to in office, a lot of those incidents happen after hours. And so I thought like that to me was one of the best examples of like a team functioning really well. And that was a completely distributed team resolving some pretty big incidents. But I don't know. Let's see how things happen if we have a big incident at my current place and we have to resolve it in person, what that looks like. As far as staging environments go, that's something I've been trying to work on. And now that I'm at a much smaller company, is like at anywhere you look at a small company, if you're familiar with like good development practices, you can point to something they're doing and say, well, that could be better, or this could be better, or why aren't we doing it this way? And I'm trying to be careful not just to say like, we should do X because X is best practice. I want to make sure there's a solid business case for each practice we recommend. And so I actually had the cool opportunity recently to bring in a best practice that solved a business use case, which was infrastructure as code, Terraform. We haven't been doing any sort. We haven't been doing any sort of that. It's all just click ops right now because
boy.
I know, right?
Well, that's what I would call, that's low hanging fruit. Once you've seen the light, right? Once you realize this is what chaos feels like, I see it in the room, and then you're like, there's a better way, and you can show this absolutely provably correct way of doing things.
Yes,
it's
absolutely
beautiful.
I'm working with Cloudflare, and their Terraform stuff is not as great as I'd like it. And then like there's legitimate bugs in the Terraform where like it's creating the resources as it should, but then it's like not forwarding along like some random variable. I don't know. It's weird. And so like we're getting errors even though it's working correctly. So, Terraform fun. But I think I mentioned this in the podcast, but like I'm convinced you can't really join a company to change it unless you've specifically been brought in to change it. And even then you're not really changing it. The leadership has you can't change the values a company has. And so that's what I like about this place I've joined is I talk to senior leadership and say, Terraform, what are our thoughts? And they say, we want it. We haven't had time to do it, but we want it. And so that gives you the license to really pursue it. And so we've just started using Cloudflare we've been using it for like DNS management, but we're using it for our CDN. And so with that we decided to store a lot of our assets for a part of the company in Cloudflare's version of S3 R2, because they don't charge egress costs from, if your stuff's in R2, there's no egress costs to the CDN. And then with that too, for streaming video, Cloudflare has a cool product called Cloudflare Stream, which if you upload a video to Cloudflare Stream, they just handle everything streaming wise for you. So you don't have to do the encoding. You don't have to convert it to the HLS format. It's all there. Really, really neat product. So
I'm consistently impressed with Cloudflare. They freak me out a little bit because they are kind of like seeping into everything, and they do things like SSL termination and some other stuff that like someone who's into like crypto sovereign stuff might have a little issues with. But I will say their engineering blog is one of the best around. The way that they problem solve is really interesting, and they really understand their customers. Especially if you start growing with Cloudflare, for instance, not only do they have good egress stuff with themselves, but if you're also on a cloud provider that it works well with Cloudflare, like Google Cloud or Azure, they actually have negotiated discounts on egress, unlike AWS, which they don't care because they're just the big dogs in town. So if you're we actually used my last startup, we used Cloudflare plus Google Cloud for a lot of stuff. And we would use Cloudflare for also, they basically were the entire DNS infrastructure for everything we did.
Yeah. I've been really impressed with their DNS stuff.
They also have some really cool edge security stuff. Maybe this will be a segue into stuff later, but they did a lot of good shift left on security things. And they've been doing really interesting stuff with AI models for looking and detecting. They just recently announced, right, that they have really advanced large language model crawler bot detection. And
I saw that. Have you seen their AI labyrinth?
Yeah, they have an AI labyrinth, and now they have one where you can optionally offer to give the large language model access to your data if they pay. So it's like a paywall for large language models, which we'll see if that actually is successful or not. But it's interesting that they're trying to figure out, is there a way to have an arrangement so that because these large language models are incredibly hungry. But that's awesome. I think this gets actually into chapter 21 talks about reserving time to create organizational learning. And they talk a lot about things like 20% time in hack days, internal conferences, improvement blitzes. And I feel like this Terraform thing is kind of an improvement blitz, right? Like you're kind of carving out some time to do this.
Yeah, a little bit, right? I think as I've gotten more senior in my career, right, like you can't just say, okay, what's the ticket? Tell me what the ticket is, and I'll get it done. At a certain point, you have to start saying, I'm going to start working on this. I'm going to do this. And so this Cloudflare stuff is a great opportunity because we just were, someone asked, like, I was just kind of clicking around to get things set up, and someone's like, what about staging? I'm like, well, we don't have staging. Like, we're just kind of all writing to one bucket. I was like, that's not great. We should have a staging environment, right? And so then I thought like Terraform. Terraform is, we're in a completely kind of new provider as far as doing object storage in Cloudflare. And so we have a fresh start here. So I'll just get this all in Terraform. And like, it was a little more work up front. But then it was awesome once I kind of was using it to create staging resources, and I built my Terraform in such a way where you just passed a top level environment variable to, the environment for production or staging. And then I ran it again, and it just created every single resource, but instead of appending staging to all of them, it appended prod. And so that was really cool because, not only was it a best practice, but it was there's a real deal business case for it, which is like, here, now we have identical, so to speak, staging and production environments, and we can point to exactly what they're supposed to look like because we have it all implemented in a declarative way. But I mean, improvement blitzes, it's interesting because like that wasn't like a mandated thing. Like, okay, as leadership, we are saying that here now it's time for an improvement blitz. That was just something I kind of, as an employee, took ownership of. I'm trying to think. I don't know if I've worked at places that have done like a ton of improvement blitzes. Is that something you've seen?
I've definitely seen this with companies that had like legacy code and needed to have a cadence for doing this. Again, this book is very enterprise focused, and it sounds like they actually shifted on this. It seemed like after reading the afterword at the end of the book, they kind of talk about the expansion of DevOps into the enterprise. And I actually would be really curious to see how enterprise focused it was in the first version of the book versus the second. Though I do think it's really interesting because it still gives us this idea that we should make time, right? And even if we're talking about 20% time, even if it's informal, I think that figuring out a consistent way of saying, how do I improve this process? And you're in an early stage startup where you have a disproportionate amount of weight to shaping the future of good processes. Like you have a lot of autonomy and there's a lot of trust, right? If you deliver this Terraform project and it makes engineers' life easier and it makes the ability to spin up an environment simpler, then next time you come up with an idea that seems a little outlandish, there's going to be more credibility behind it. And they go, you know what? Carter comes to us with some left field ideas sometimes, but you know what? He's got this like great batting average, right? Like I think that's the part here where the safety part comes in, which is, hey, maybe not every idea is going to work out. And again, I talked about this in the other episodes. This book disproportionately just talks about these amazing success stories that happen all the time. But I do think it needs to be safe enough that like you might come in and go, you know what, we did all this Terraform stuff, but there's a couple of parts of our process that are not compatible with infrastructure as code, and it's actually slowing things down. And we need to have a deeper conversation on why are we doing it this way, and that if we can invert our process a little bit to be more Terraform friendly, then we get all the cool stuff that Terraform gets us, right? And sometimes there's these like social contract negotiations that have to come out of like, hey, I realize that, you know, Jill does this one ClickOps step that I literally can't model inside of Terraform. And I think maybe we don't do that anymore. And we just have a container with this like fixed hash name at the end, which is the commit that it's coming from. And that pushes through the pipeline. And like, you might have to have these weird kind of, again, their eyes might glaze over. The CEO is like, why would I care about hashes at the end of a tag or something? And you're like, no, you don't understand. If we have a hash at the end of the tag, I can write a program that will always detect the right place to take this asset and do these magical things, right? And maybe you don't even explain it in the weeds that much. You just go, hey, this is a way to ship artifacts, and we want to care about artifacts because the security team wants it. We'll need it for SOC 2 Type 2 when we go down that road, or eventually, you know, like you can kind of like make these business cases as like good example. You're eventually, and I don't know if y'all are on this path yet. Have y'all started talking about SOC 2 Type 2 or?
No, my brother's in security and I hear about SOC a lot.
So you're going to, at some point, you're going to try to partner with some other B2B business. Like it's going to happen. And they're SOC 2 Type 2 compliant. And there's this entire web of trust. And you're pressured to have every vendor who's in your chain also SOC 2 Type 2. And you actually have to write a report as to like why you're allowing this vendor who's not SOC 2 Type 2 certified to be in your web of trust. And it's no one likes to do it. Like once you kind of gotten into that little walled garden, you don't want to have to go down that path because it's just not a fun thing. And so you get these social pressures. It used to be really hard, super expensive, take a long amount of time. There's now organizations like Vanta and a lot of other kind of cool players now that make this a lot more streamlined. But this is another one of those things where like most customers won't care that you're SOC 2 Type 2. Like nobody's going to go, you know what, I would have used this mentorship platform, but they're not SOC 2 Type 2. So like, I'm not doing it. Sure. But you will miss certain business opportunities if you don't. And so there is this weighing of like the value of partnerships is now a new type of customer. And you have to like think about balancing feature development with like security and compliance. And it gets a little more complicated, but if you have these great CI/CD practices and you started doing these good hygiene of like, you know, being able to blow things away and spinning them back up and really understanding who owns what bucket and all these other things, when you start going through the SOC 2 Type 2 checklist, a lot of that stuff's in there. The expectations are already there. And I was able to get a company through SOC 2 Type 2 because we wanted to work with a bank who required it. You absolutely, if you were not SOC 2 Type 2 certified, you could not work with them. And we did the whole thing from zero, I call it zero to hero, right? So 0 to passing SOC 2 Type 2 within 7 months. And that was nuts. Like we went super crazy fast. That is I would say that's pretty close to as fast as you can do it because you have to have at least a 3-month observation window from auditors who just like watch that you're actually following the processes and procedures. But yeah, it was interesting. And I think, again, this is where these sort of like hack days or improvement blitzes really pay off long term is don't do it just because that's like you look at the DevOps checklist and you're like, oh, I've got to do these things and win all the awards. You do it because when the system gets more complex, you double or triple your headcount. The default thing is the correct thing, right? That's like the big thing for startups.
Well, I mean, then talk about sell us on security. Nathan.
Why? Why should I care about
Well,
security?
I think we all get why we should care about security,
Right.
right? But what about what the DevOps Handbook teaches makes security easier on developers or makes it an interesting challenge for developers to tackle? Help us
So
understand this.
I'll put it this way. So let's say I always like using the kitchen allegory for software stuff because we're shipping things on a regular interval, right? In a commercial kitchen or a kitchen inside of a restaurant, there's an expectation of operational excellence, and you're also just shipping meals to people who expect those meals on a regular basis. So the the chefs can't just be like make a great meal and then like cut loose. They actually have to make consistently great meals, and keep the kitchen clean and keep the inventory full and make sure that there aren't rodents or bugs in the kitchen, right? There's all these things that you have to keep from an operational standpoint. And so like a high functioning kitchen is a great way of thinking about software development. Also there's trends, right? Like, broccolini is super in right now. And so like, you gotta like, do you decide to hop in on the broccolini trend or are you going to stick with whatever, right? I think with security, the idea here is that security is this cat and mouse game, and folks who are trying to exploit systems are always trying to find creative ways to use a system that you weren't thinking about, right? Like that's the whole part is the system so complex that if I break 5 layers of assumptions, I can get root access to your Linux host, and then I can start scraping all the data in, or I can compromise people's machines with exploits, or can I do really wild things? And they talk about this in the book. Like, for instance, probably one of the least scrutinized areas in security are like your CI/CD pipeline, right? Those typically have like very privileged access. They have access to security keys. If I could inject some code, I probably could do a lot of damage. And so the idea here is, you should treat your security posture like you would treat your reliability posture, right? Like in the same way that I want people to, if I have a shopping cart online, I want people to be able to check out. If there's a bug right before they hit the, ship me this order button, and they bail because they get frustrated, they can't put their credit card in, they leave, that's a huge impact on the business. On the security side, if I can't trust our deployment processes, or there's a supply chain attack, and we talk about this. This has become even a bigger deal, which is a lot of companies YOLO the dependencies that they have, especially if they're JavaScript heavy. And some of these JavaScript libraries the person will get burned out. State actors come in like North Korea or China. They will start hot swap stuff, and if you're just pulling in the latest version of the code, you can get compromised even in what they call the supply chain and some trusted path. The security instrumentation is this in the whole like security posture piece is this idea that like we should always make time to think about security, and they call it shifting left on security. So it used to be that you'd write a bunch of code, and at the very end, your security team would be like, yes, I'm going to give it my blessing, and you can go out. But that's way too late. The idea is that you should actually have security best practices in from day one. And a perfect example, I just rolled this out with my team who's like got a new code base, and we use a lot of Go code. And there's this module called GoSec. It's a static analysis tool, and it just catches a bunch of security flubs that happen in your code. And it's not going to catch everything, but we now have it with we do linting, we do this GoSec, we do test suite. These are the quality gates that we put in. But it's caught a few things that like really minor bugs on my side, but some bugs where I'm like, oh yeah, I hadn't thought of the unintended consequences of this. Other hygiene, I would say like easy wins is one of the things I love to do when I first get involved with a code base is are our containers too permissive? So a lot of times we'll use build containers where we like build all the stuff and then we ship those into production, right? Like that's a naive way of doing it where I literally copy my files in, maybe pull in my dependencies and then ship that to production. But most of the time, what you really want is what they call a multi-stage build, where I do all my building and then I only pull in exactly the files that are needed for runtime. I use a super minimalist, like locked down container. And you get two things out of this. Number one, your containers get way smaller. Instead of it being 500 megabytes or something, you might have a container that's like 23 megabytes. So not only is it like easier to deploy stuff, but you also get this like what they call a lower attack surface, right? And a lower attack surface just means there's fewer things for a security researcher to fiddle with, right? If I only have like for Go, I'll have a single static binary running in like a chain guard container, which is like a super paranoid container image. And even if they exploit my Go code, there's something wrong with it. It's running as unprivileged. It's running as a single binary inside of it. There's no extra access to the system. It isolates. It has a small, as Amazon would call it, a small blast radius, right? Mm-hmm. And again, you could come in with a dev spike and just be like, hey, I'm going to make our containers load faster and act smaller and like reduce latency when we do deploys. And it's also a security posture thing, right? Like you kind of get both. You get like a more efficient deployment cycle and this better security posture. And that's what I typically look for in security stuff. It's like, you don't have to fix everything, but you should look at it in the same way that you're like looking at infrastructure as code. It's like, hey, is there are we really building our containers the right way? Are we really validating that here's another good example. And this one is actually like hard for a lot of engineers to wrap their heads around. A lot of times you'll do branch-based builds, right? So like I'll build everything in my PR or have it in my staging branch, and then when I deploy it to like production branch, or let's just say we're doing branch-based, the pipeline will rebuild the container. The thing is though, is that it's actually very hard to have what they call hermetic builds, which is proving that my container from staging environment, which worked, is identical to the one that's built in production. And it's actually much better to take what they call like take an artifact and promote that artifact. So build it once, prove that the data has not changed. Like if your runtime code is the same between branches, I shouldn't rebuild the one that's been merged into main. I should actually just say this asset is being promoted to this new environment. So I build it one time because that container asset is what's gone through the rest of my stuff. And again, this is like one of the many ways you can do security posture where we think of an asset oriented artifact. Like these artifacts are, moved through these pipelines, not just build processes where again, surprising behavior can come out.
What this is tangentially related to security. But as far as, is there any point to having a staging environment? I guess the point to having is, so CI/CD world, right? Where theoretically the idea is I develop locally, right? I push to staging. There's validation done there. And then if it passes all of that validation, it goes to prod. But like in a CI/CD world, if it's good enough to pass the validation and make it into staging, isn't it just by nature good enough to pass the validation to get into prod? Like, what is the purpose of the staging environment at that point? Is there the purpose of a staging environment, or should we be thinking of staging more akin to like a dev environment, but just kind of up in the cloud?
So this one's contentious, and I also think that staging and production and these separations are organizationally driven. They're not driven by what's the correct answer for you. I will tell you that like I'm working on like a little side hack project right now, and I'm purposefully choosing to only have a single production environment. And I'm doing that because I'll have the ability to do things like dynamic routing with headers, to do alpha, and to like basically have a virtual staging environment inside of my production environment, right? I can see alpha and beta features through feature flags, but I have one continuous environment. I think that is a sign of maturity if you can get into that world. Now, that being said, if you have one production environment, it doesn't necessarily mean that everything's touching the same backing database. You might end up having a service that has like an alpha version with an alpha version of its database, microservice type of thing, that then it only touches that when it's in alpha and then it hops over into the production one. Or, there's all kinds of different ways that you can manifest those things. I think some environments have regulatory rules where they must have a staging environment. I think that's another good example. Or folks that have a high risk where they're not comfortable just having feature flags as the thing that blocks it. They really need complete separation, or at least that's their perception of it. A good staging environment should look as identical as to production as possible. That's like one of the sort of big ideas. So it's more expensive, right? It's more expensive to operate an end-to-end staging environment and figuring out where those barriers and delineations are. But where I've gotten is I always try to push us to a world in which the pure version of a trunk-based development happens, where everything can be in the same infrastructural environment, and you don't have to have staging versus production. But I don't know. It's there might be regulatory reasons. There might be separation of duties reasons. Like, for instance, we do need to have, like, I'll put it this way: if you have a software product where you're constantly pushing out updates and nobody knows, you don't think of like which version of Facebook are you running, right? Like, Facebook just constantly updating. Versus if you're like building an operating system, right, or you're building something that like has a cadence or release cycle. Of course, you're going to have a nightly builds and a alpha testing and then a stable, right? Like you're gonna have these environments that are very separated from one another, and I think that's fine because you're shipping a product that has a cadence to it, right? You people say, okay, I'm gonna update my operating system every time a long-term support version comes out, right? Or the Node runtime, right? You don't use the nightly build of Node.js most of the time. Most of the time you're saying, okay, what's the most like practical long-term support version? Okay, well, we'll use that for the next like year and a half. And then when the next long-term support comes out, like we'll get ready and do the upgrade. And again, so depending on your cadence, depending on who relies on your code to do other things, I think that there's like really good cases as to like why. We had the same thing with FDA regulatory stuff. We actually had to keep an FDA environment that was what we will release to production after FDA approval. And it basically was treated with like white gloves. So we did continuous delivery in our staging environment. That was like our nightly build. And then at some point we would say this commit hash is what we're going to deploy into the FDA environment. That's what gets the scrutiny. And once that got blessed, that became all of the assets, all of the artifacts in that became the production release. And again, we had to do that because it fit what the expectations of the FDA were, right? We couldn't do continuous delivery. They don't want I don't really want my heart defibrillator to have an update that could go sideways on a nightly basis, right?
I just test and prod.
Right.
Test your heart defibrillator and prod. So in a pure trunk-based environment, is there no concept of a staging database?
Yeah, so again, this is where if we really talk about like decoupled services, the teams have autonomy, right? So if you think about it, like back to team topologies, where I should be able to operate, let's say most of the time you have a trunk-based environment, you also have microservices, right? Or you're at least a service-oriented architecture. And I have a team that has control over their own deploy cycles of some piece of the puzzle. You get to put the things that happen in there. A lot of times what you'll think of is that staging becomes this sort of like ephemeral part of the pipeline. So during the pipeline, during regression testing or all these other things, your pipeline will have some it'll have some fast paths, like what you'll do for a PR, right? You don't want your pipeline running for hours and hours, but there might be a part of your pipeline that runs these regression tests against a bunch of other larger parts of the system. And you might want to run that for hours or even days sometimes. If you're doing fuzzing is a good example where maybe I want to fuzz some really important code for 8 hours or 12 hours or 24 hours. It could be that you run those parts of your pipeline and then those don't get promoted to production until the blessing comes from that quality gate, right? So it's ephemeral in that you probably spun up a database and you probably did all these other things, and it might even interact with some long-lived regression testing tooling that you have. But there's not staging environment that like a human hits a button and deploys to, right? And so they kind of touch on this a little bit. And again, it really depends on what you have. And we did this a lot with this fintech company I was in. We did have a staging environment. So basically what we did is you had a local dev. You could spin up all or part of the microservices infrastructure. You could spin up your application for dev. You could hook it into the staging environment if you wanted to. You could do all these like, kind of interesting things. Staging was kind of this like, we called it like pre-prod. It was like a production ready. So the idea is staging is that at any moment, somebody should be able to hit the promote button and it goes to production, right? And so you should write production quality code to go in staging. Staging is not a dev environment where you could have a bunch of stuff that breaks, right? And then you hold your whole team accountable and you say, hey, I've noticed that like your service has been real flaky, or I've noticed that when I try to update my dependencies to the stuff that you have, I've had to go back and refactor a lot of stuff, and you're not honoring the contract where you don't break the API. This is one of our like cardinal rules, right? And we would stop. That would be when we pull the in cord and say, hey, look, let's update our social agreement and say that this should never happen. Otherwise, I have the ability to roll back your service, right? Like, and we would do these kind of things. And so what we ended up having is the ability to make pretty huge changes without having side effects. We all got really comfortable with the deployment process. And we tried to have we measured ourselves by saying that we wanted the diff between staging and production to be as little as possible, right? So we wanted to spend as little time as possible having a service have to sit in staging before it was promoted to production. And so we would then say, okay, well, how do I meet my principles? My principles being don't break stuff, honor the social contract. So we got a bunch of automated testing in place, and then we would run regression testing inside of staging continuously. And so we would have like, for instance, one of the things that we cared about, we had this like very normal cadence of like when we rebalance our portfolios, is that, we would basically say like, okay, well, if it gets into staging and it makes it through these like 2 or 3 regression testing cycles, it gets the like promotion blessing and it can go up. Or if we could prove that the code path was not impacting regression testing, like, maybe it was improving Swagger doc or something, you could just like push it out and push it through. But again, it's a lot of this stuff is like organizational. It's the Conway's Law stuff, right? It's how does it help our team ship better? And so yeah.
Well, so then we're talking about security then, and the big idea that this book is trying to sell is that security does not have to be a barrier to flow. Security can be part of your flow.
Right.
Have you worked in the past with dedicated security engineers, like embedded in a team, or is this just something that the engineers naturally on the team have adopted security procedures? Because like I said, I've mostly worked at big companies, and when I have worked at those big companies, the security team has always been a barrier to flow. It's always been fill out this 80 question form, or submit to these extensive reviews before you can publish a feature. And so if the idea is, okay, let's get it in the pipeline, let's just have security be part of our DevOps process, and we can just be sure that every change that's rolling out is secure. Again, thinking about it from like a Conway's Law perspective, like I would think what you would need to do is embed security engineers in every team. Because if you naturally have a separate security organization, of course your system's going to evolve to have a separate security part of the process. So what do we do here?
There's always that dysfunction, and the book brings this up really well. It's like, hey, if you have this multi-part form and this other team that you have to engage with every time, you're violating some of the DevOps principles. And actually, one of my favorite case studies, and I've kind of breezed over most of them, there's a Capital One, I think it's called the Capital One No Fear Releases case study. And basically, it was a partnership between the security team and the engineering team. And they eventually got to 10 plus releases on their banking website per day, right? And you're like, well, how do you do that when you have to do all the security and compliance stuff?
Yeah.
And one of the big things that they advocate here is that, if you're doing something brand new, you probably do have to have a quality gate that kind of stops the earth kind of thing. But what a good security team should be doing is giving the correct defaults, right? if you're going to use a new SSL and encryption library, you probably have to have a lot of scrutiny. But there should also be some officially blessed versions of OpenSSL in the default configurations that the security team should weigh in on, maintain, and then provide to all of the teams saying, hey, if you do this, you don't have to fill out the form. We have already blessed this operation. We've already blessed this tool. And that was like a good example of how, again, we do the same thing with, again, we use ChainGuard. And we're not sponsored by them or anything, but ChainGuard's really cool. They just give
ChainGuard,
like,
if you're out there, you can sponsor.
Yeah, you can totally. ChainGuard is a really great community-driven way of like having high security posture container base images. They're optimized for all the major languages. They, you can kind of have it as lightweight as you can. A good security team should come in and say, if you're deploying Go code, these are the blessed base images. Here's what the hygiene has to be. Maybe have automated security scans to look for suspicious behavior. I think it was it Neil Ford, when we were talking to him, he called this orthogonal coupling, right? Orthogonal coupling is that we come up with a blessed way of doing certain things, like how do I issue logs? How do I do security stuff?
Mhm.
How do I do these things where even though all of our teams have autonomy in how they're going to build things, if you used a blessed way of doing it, you take the easy road. Your team doesn't have to build all these things from scratch. And I think when you can come up with these, but at the same time, you must give them a way to deviate if it's needed for their team. So yes, you might put up some extra barriers and say, hey, fill out this form, or show us why does our out of the box tool not work for you? Because one of two things comes out of that conversation. They either come back and go, you know what, you guys are being super weird and we're going to have to do some extra scrutiny and that's fine. Or they go, you know what, I can add one feature flag to our core security tool and I'll let y'all, give us a 2-week dev cycle and we'll have it for you. So like use your own thing right now, but I'll give you like the blessed way of doing it in 2 weeks. And just negotiating these sort of like security best practices that go on top of it. To answer your other part of the question, I've not been on big enterprise teams, but I have been on teams where we have dedicated security folks. And the ones I've worked best with kind of take the same approach that like a SRE or a platform engineer does, right? They do the enablement, as we talk about in team topology. It's like they do enablement in that a lot of times there's like some learning that your engineering team has to do as to like why we're here. Like, oh, there are these 3 extra steps you have to go through because here's the exploits that happen if you don't, right? And you're like, oh, okay, now I get it. Instead of just being like, no, you can't do that, like no more fun, that's dysfunctional. And I think that's like defensive and that's like the traditional ops path on things. And I always try to dismantle that if I can, I guess.
I think it's important. One of my beefs with security folks is like they seem to take a great pleasure in saying no and in deny, right? Like, right. I think there's a part of that that's natural because it's kind of like, oh, if I caught this thing that was dangerous, then I'm doing my job. And so kind of the more I say no to things, the more I'm doing my job. Right. But so I think there is a real mindset shift that may need to happen there, which is like a security team's job is not how do we catch as many things as we can, and more how do we enable development teams to get to yes as quickly as possible. And so maybe that looks like if you have a separate security team, maybe you're developing a lot of tools, plugins, building blocks that development teams can use. Salesforce did this in one of the case studies where they classified low risk changes as standard, and that bypassed their whole approval process. And so I can imagine as a security team looking and saying, okay, what changes can we say if you do it in X way, it's standard and we don't have to do that. Maybe there are some bigger things where we say, we don't want you to handle this on your own. And if you do handle on your own, you're going to have to submit to an extensive review. But if you use X component that we've built, that's the blessed path. And so now that's an automatic approval, right? Yeah.
And I think it's in this goes beyond the DevSecOps. That's kind of like the term that folks will use. The whole idea, though, is that just like make the correct behavior the default behavior,
Mhm.
And it by correct is defined by the teams that are involved. And a security team should always be doing two things. Number one, setting security standards that are easy to implement, or as easy as possible, I should say, to implement. The other one, though, is that you should really be red teaming inside your organization, right? So let's say you told a team this is a bad practice and you're going to get in bad shape, and let's say you deploy that into your dev or staging environment. Um, you should, if you're a security team, you should take an adversarial approach and always be trying to hack your own infrastructure, right? So like if you know that a team deviated from some off library that you have officially blessed and they're using some other pattern, and then you can show an exploit, the data is way better than a no, right? Hey, this is why you can't do this, and this is why we can't have nice things if this went into production, right? Boom, here's the data. If you had used our auth library like we'd asked you to, then this whole category of exploits gone. That's a great way to talk to an engineer, because nobody wants to be like see a nasty report with a bunch of red text on it that shows you that you did something dumb, right? And that's way better than like, oh no, that's not best practice, and you're like, okay, but show me what I did. Like, show me how this could be exploited, right? That's show me is an important part.
Well, I think that brings us to a good stopping point here. Yeah, so I mean that takes us to all the way through the DevOps Handbook.
Yeah.
I was really glad to be able to read this one, because it is kind of one of the more recent seminal texts in the industry, and so I've really enjoyed this. I mean, what are you going to do differently in your career, Nathan, from having now we've finished the entirety of the DevOps Handbook?
Yeah. So, part 5 like really spoke to me. I think this idea of the internal learning, the learning organization. I've been in organizations in which we had, open topic Fridays or something where anybody could share, and we did like a lunch and learn where it literally could be like, oh, I built a fence over the weekend and here's what I learned about building a fence, right? Or oh, we just used this new auth library. So this idea of I want to do more things around improvement blitzes and internal conferences. Like, I'm in a blockchain space and there's like way too much changing in the industry all the time. It'd be really nice if we had some of our like category authorities do an internal conference to make sure that all the engineers understood what was possible, and we don't have that right now. So I'm gonna be pushing for something like that.
Yeah, I had a very similar thought, which is mine is kind of a vague, mushy answer, but just how do we improve team learning processes? Like, I thought it was really cool. We do demo days, which is awesome. Everyone shows off what they work, but one of our new engineers, it's funny. There's 3 of us who all used to work at Amazon, and we call ourselves the Amazon refugees, and we. But he's a really bright, talented guy. But so we did all kind of our demos of the features and stuff we'd been working on. But then he asked at the end, he's like, "Do we do code demos?" I'm like, "What do you mean?" He's like, just neat pieces of code that we've read in. We're like, "Yeah, sure, why not? You can do that." And he showed us that he found in like the code base like some it was Java, and like it was like a constructor for a variable, but it was just like it took like 19 parameters. And so like the first 6 are like, value, 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 value. And then it's just null, 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 like false, null, 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 null. And it was just like, what the heck? And so he wrote it, just rewrote the object to have a builder pattern, right? And so then he just built it and then have all those nulls. And I thought that was one, like just great practice. And 2, really neat of him to take the initiative to show that to the team, because that just enforced a good team culture of like, hey, look at this small improvement to the code I made. And now every other engineer, and we've got more junior engineers, right, knows when they run into that null, that giant constructor with a bunch of nulls, they'll say, wait, didn't Sham do something like that? And they can implement the builder pattern. And so I want to do more things like that. Like I'm trying to figure out, like, does that look like a lunch and learn? Like, for example, like Terraform, when I started doing Terraform work,
Yep.
I take the impression, because our team is about, our company is about 35% engineering, but then there's 65%, which is like sales and business ops and things like that. But I'm pretty adamant about the fact that like, we're a tech company. And so if you are a non-technical employee here, that doesn't absolve you from understanding the technical parts. And so I was explaining Terraform over lunch to several non-technical people to kind of say, like, this is the value we're getting out of this. And so I don't know what that looks like necessarily,
Right.
but I would like a better internal culture, like you said, almost internal conferences, internal talks, lunch and learns. I think that could be really valuable for the team.
Yeah, one of the interesting things when I was at one of the startups I was in, they had built some, and this happened, right? It was before, they weren't using Terraform, they're using something called Troposphere, and I had never seen it
Okay.
before, but it's sort of like a prerequisite to using something like a Terraform or a Pulumi or one of these other sort of. You wrote Python, it used the AWS SDK, and it spun up a bunch of infrastructure. And of course, there were some messy abstractions, and there's some other things that they had kind of done, and they weren't DevOps people, so there's some things like idempotency and other stuff were not there. But one of the glaring problems I found was they would hard code IAM user credentials into the servers that they deployed, which is like a super old school way of doing, like, we're talking about like 2010 era way of doing things before IAM roles existed, or at least people's understanding of IAM roles existed. And so I gave a little lunch and learn on why ephemeral credentials are awesome and why IAM roles is the way to do things. And it was just a really basic primer for a little interesting piece of security that not only did it make our security posture better, but it actually made their life easier because you didn't have to keep sensitive credentials in build pipelines, which you never want to have. And it was kind of like there was a couple of engineers who just never thought about this domain of problem before, and it was really appreciated. And again, it was a small little 15-minute lightning talk, right? And this opened up a whole other world of like really cool just really cool conversations that we had about improvement, right? It was an improvement of our processes. And I ended up being able to eliminate a bunch of building code and give us a more reliable pipeline and check some boxes on the Vanta thing, which is like, oh, no long-lived credentials in production, right? Like, boom, we knocked out like 3 things in one, and it was awesome.
Well, that I mean, yeah, that sounds nice. And so yeah, I think we're both kind of on the same page and just wanting to kind of level up team learning. We've now finished the entire book. I mean, who would you recommend it to?
So I'll take what I took from last week and kind of expand it a little bit. Obviously, this has a real enterprise focus. I think if you're struggling in the enterprise, let's say in some sort of legacy environment, and now you've realized, hey, we're actually a tech company because that's the future, and you really need to level up the thinking and the posturing here. Obviously, this is like a very enterprise focused book, but there is some meat. There's some meat to this book that I think would be useful to a broader audience. Again, DevOps folks that are new to the industry, and then engineers who maybe have found themselves kind of thrown into DevOps. I really do think that part 3, 4, and 5, which really get into the implementation details of the 3 sort of major goals for this book, and then this part 6, which is the security thinking, it's worth a read. So again, if you're not in enterprise, but you still need some DevOps understandings of like how these can be successful and why they're useful in a business of basically any size, I do think you could skip parts 1 and 2, just jump right into, or skim parts 1 and 2, get into 3, 4, 5, and 6, and there's a lot to gain from the book.
Yeah, I think this book is obviously most useful for senior engineers or leaders who have the ability to kind of make cultural changes. But I think it is still good for junior engineers who want an idea of what like an ideal vision looks like. That's something I found really helpful throughout the podcast is reading all of these things and kind of knowing you have a North Star that you're working towards, and anywhere you work, you're not going to have everything perfect all the time, but you can kind of know if you're veering into the wrong path. And I just think anyone who needs that vision could really benefit from this book. I did some consulting work actually recently with someone who he's from private equity firm, and they had acquired a little company with like a development team, and so he's like managing it, but he's not a developer, and so he's just trying to get my advice on kind of what everything should look like. And he's asking about team dynamics and things like that. And he's talking about their kind of like SVP of tech, CTO for all intents and purposes. And he was just saying like he's really, really good technically, and we can't afford to lose him. And we really value his technical expertise. But then I was also asking about kind of like their development processes, and they were just weird things. They're like, well, we release every 2 weeks. I'm like, that's not good, right? Like you're not doing any sort of like CI/CD. They were talking about like PR approvals. They're like, well, at your PR, there's 12 engineers on the team, and there's like 3 who are blessed to approve PRs. I'm like, that's weird. Like, a junior engineer should be able to approve a PR. And so that SVP, they say they really value his technical expertise, and I'm sure he's a very smart guy, right? Does he even know that this world exists? Does he even know that there's a way to do releases more than every 2 weeks, right? I've just seen that happen before, where you have people who like are like, they've got like a lot of like technical IQ and horsepower, but they are kind of set. They're living in the Stone Age a bit, and they're applying all of that horsepower to like, nailing the 2-week release, and they have all these processes and firefighting and judo knowledge to making that release every 2 weeks work. But what if you applied all of that horsepower to DevOps and to getting rid of the 2-week release problem and to building this culture instead? So I think, if you're still kind of operating in that world where like releases are a big nightmare, like read this book, because it'll give you the vision for what an alternative looks like.
Yep. I agree. And yeah, sometimes learning how to get out of your own way is so hard, right? It's very, very easy to talk about what we need to do. And unless you really live these principles, it's so easy to get sucked into the minutia of just dysfunction. And I think the books like this are a good reminder. And like I think I'd said before, this is a technical compendium to the Unicorn Project. So if you read the Unicorn Project and you're like, this speaks to me, I see my organization here, I feel like these challenges are ahead of me, this will give you the deep technical way to communicate to leadership, and hopefully you're in a position of influence. And if you are those two things together, this is really valuable and should be eye-opening.
We might wind up reading all of the Gene Kim books, but backwards, because he wrote the Phoenix Project, and then he wanted to write like the prescriptive version of it, which is the DevOps Handbook. Then he wrote Unicorn Project. We did Unicorn Project and DevOps Handbook, but we've just heard so much about the Phoenix Project. We'll probably have to read it eventually.
Also, apparently he got inspired to write the Phoenix Project because of a book called The Goal, and I'm adding that. I have it in my notes. I'm adding it to our backlog. So apparently it's like how to do things within constraints and operational excellence type stuff. So I think it's going to be one of those where like if we get into a phase where we're doing this sort of businessy type books like 7 Habits of Highly Effective People and things like that.
I'd love to read How to Win Friends and Influence People one day.
Oh yeah, there you go.
That's okay. So, I think that wraps us up. As always, you can find us on Twitter at Carter Morgan or at Book Overflow Pod. You can find Nathan's newsletter, Functionally Imperative, functionallyimperative.com, and you can contact us at contact@bookoverflow.io. Thanks, folks. We're excited for what's to come. Stick around.